part of the study guide, please let me know. I've explained the difference between multiple linear regression. Yes, I'm recording. I've discussed the difference between multiple linear regression and simple linear regression. How do you move from simple to multiple? I think I've explained that one. I explained that for multiple linear regression, we'll be using the matrix approach. We also discussed how to find these matrices. If I didn't cover something, please let me know. I will stop. I explained how do you find the betas, how do you get this matrix, how do you get a matrix of Y, matrix of X, and so forth. I've explained that this is the model that will be used in matrix notation. This is the model. Check your notes. Again, I gave you a task to go and prove that, to go and prove these things. But even if you didn't do that, we'll still have time to go and we'll do them together. If you struggle to prove them, we'll do these things together to prove that the expected value of the errors is equal to 0. We'll prove that because we're almost done with this chapter. I taught you how to estimate the parameters, to estimate the regression coefficients. I explained that one is 3.2. I explained how to use this formula to find to estimate the coefficient. We discussed the ANOVA table part, how to construct the ANOVA table using matrix notation. I explained the meaning of this Y prime Y and so forth. So I assume we're fine there. This is the ANOVA table. I explained that this is how you should write when you test. We have covered that one. If you feel like I didn't cover something, please let me know. I explained the use of this matrix, that whenever we're finding the confidence interval for the betas, what do I interested in is the diagonal line, but you must also know the meaning of the other values, like sigma, B0, B1. This is the covariance. This is the covariance of beta 0, B1. And then if you are given two independent variables, you can also have the covariance between B1 and B2, the covariance between B0 and B1 and B2, and so forth. So you must know the meaning of the other things here. So if I ask you to find the covariance of B1, B2, you must know what I'm referring to. You must be able to find that. Let's go down. I explained the variance-covariance matrix, and we tested using the t-test. Remember, this part were done. The confidence interval for the betas, I explained this. And how do you find this SBK? Testing for the significance of regression coefficients. Even in the morning, I explained that we can use 3 methods to deal with this section. I said you can use the confidence interval to solve the what you want to solve under 3.4, confidence interval for the betas. You can use partial F test to test for the contribution of each regression coefficient. We must go through this. So this part, if you can check, I didn't cover. Sorry for that. I didn't cover 3.5. 3.5 so far is not covered. This one is about the inference about the mean, where you'll be finding the confidence interval for the mean and the prediction confidence interval. So this part, I want to make sure that this part is the last thing. So we're still going to do these things. Should not. Hopefully, next week we can do this section. I asked you in the morning to give me the definition of coefficient of determination in multiple linear regression. You kept quiet. Here's the definition that I was talking about. It measures the proportion of the variation in Y that can be explained by the set of exploratory variables selected or independent variables. So based on the question that we're doing in the morning, your R squared there was 95. So what you will do, you simply say that 95% is what you're going to say. 95% of the variation in the what? You should replace this one, selling price of the house This is what you're supposed to say in the morning. Selling price of the house can be explained by what? Can be explained by the size and age of the house. Because these are what? These are your two independent variables. So whatever is happening on Y can be explained by what? By these two independent variables. So whenever you're asked to interpret R squared, we expect you to write a similar statement. But I'm not rejecting what the leader said in the morning when he was talking about the model. It's also correct, but I felt that one was it was not clear. That's why I said to bring this one in, that what do we mean by when we say we're finding R squared? Checking the variation that can be explained by those two independent variables in our case. So tomorrow, when you do the tutorials, please make sure that you interpret, guys, because even in the test, we are losing marks when coming to interpretation. Even the test that you wrote yesterday, when coming to the interpretation part, you're still struggling on how to interpret what we have calculated. So please, guys, let's adjust when coming to that. So I will cover that section. So we covered this in the morning. The adjusted R, I will cover it. Let's come to this one.
Sir.
R, yes?
Can you please repeat those interpretation?
Which one, sir?
From the first class.
Which one are you referring to, leadership?
The one of X3, X4, and X5.
Of what?
Of X3, X4, and X5.
Is it not related to dummy variables, that one?
Yeah, the one of location.
Yes, that one is fine. You can do it in the form of consulting after the class, leadership. Again, I will make sure that we have that type of equation in a tutorial tomorrow. But can you allow me to continue, and then immediately or towards the end of the class, I can end the class maybe by around quarter past, so that you can have questions concerning our morning class. I don't have a problem with that. I just want to cover a certain section here so that we finish these things. I will repeat leadership. I don't have a problem with that. So, yes, leadership. Oh, sorry. Let me check the comment. Yes, I will prepare them after class. I will start preparing them after class because it's difficult for me to prepare them before. Reason being, um, what if I don't cover the things that on the tutorial? So I prefer teaching, and then after teaching is then now I can prepare the notes. So now I want to explain this one, the R, correlation coefficient. So remember our class example? Can someone give me the model based on class example? I want to show you some. Now I want to explain the meaning of R in multiple linear regression. The meaning of R in multiple linear regression. The meaning of R in multiple linear regression. I want to explain this one so that everyone understand what I'm talking about. Oh, sorry. I was told to first share the screen. What was our model? Anyone who can still recall? Am I sharing the screen, guys?
Yes, sir.
Okay, thank you. This thing is not reading. I want you to give me the model for based on the class example. This one I can minimize. Oh, the reason why I'm failing is because of that. Okay. Can you please give me the model? We said the selling price equal to, I was told that is 10.0 plus 12,83 size minus 0,058. This is what I was told. So when you find the scatter plot of price and size, what type of relationship are you expecting? A positive relationship. Why am I saying that?
Beta 1 is
Why am I saying?
positive.
Because beta 1 is positive. And then the scatter plot between price and the age, we're expecting a what? A negative.
Negative.
Because of what? Yes. So now, suppose that in the morning we said our R squared is equal to 0,952. What is our R now? Remember this one, our R squared here covers Y and what? X1 and X2. X1 and X2. So what will be our R?
0.976.
Let me write it. I'm told that is 0, you're saying 0, what? 97.
976. If I converted using that one, I did not take the full bit.
No, it's fine. It's fine. You're just for example. So you are saying R is 0.976. Why is it positive? Why do you decide to go with the sign positive? Are you still there? So, because you are dealing with multiple linear regression, whenever coming to R, if you are having more than one independent variable, you don't have to interpret it, because it's misleading now. So you should not interpret R for multiple linear regression. Some softwares, whenever you run the results, they will give you the value of R, but ignore it. Because if we start asking you questions, you won't even answer even a single question based on that, whatever you'll be calculating. Like now, what are you saying? Are you saying there is a strong positive relationship between Y and the two independent variables? Is it true? No, it's not. Can we say there is a negative, uh, uh, strong negative linear relationship between Y and the two independent variables? What guides you to say the value is positive or negative? So whenever you see the value of R, as long as you're dealing with multiple linear regression, ignore that value. So the last section that we have to cover is called partial coefficient of determination. As I indicated in the morning, this section is related to partial f-test. So you'll be asked to find r squared of y x1 given x2. In a case of two independent variables, this is equivalent, it's the same as 1 minus SSE divided by SSE of the given one, the one that is already in the model. So the formula to find this is what? SSE is 1 minus SSE divided by SSE of x2. How do you find SST of x2? Remember, you have SSR of x2, and you know that SSE, the general one, is equal to SST minus SSR. So which means if we're focusing on x2, it means we'll have SSR. Oh, so let me change this one to E, or I'll change it. I will change this one. It's fine. So where will we get this information, if I may ask? Anyone who's having an idea? Oh, I removed the right information. I left the wrong one. Sorry for that. I wanted to remove this part. So SSE of x2 is given by SST minus SSR of x2. Same applies if you are asked to find r squared of y, x2 given x1 now. What will be the formula? Relate to the one on top. What will be the formula?
It's
Yes,
one.
leadership. Yes, I'm listening. Yes.
It will be 1 minus SSE
One.
divided
SSE.
by SSE of x2 of x1.
And then what is the formula for SSE for x1?
It
This
will
is
be
given by what?
SST, yeah, SST minus SSR of x1.
X1. Remember, guys, I asked you to construct an ANOVA table for partial coefficient of determination. You have this information. If I recall very well, you have what? You have this part, isn't it? You have this part. This one you have it even from the overall ANOVA table, because SS to SST, you told me that is 23 what? 73. This one, it doesn't matter if you are dealing with one independent variable or two independent variables. Why? Because how do you find SST? What is the formula for SST? SST is the same as SSYY, which is the same as summation of YI minus summation of YI all squared divided by N, which is equivalent to what in matrix notation? Y prime Y minus 1 over N summation of Y squared, isn't it? Or you can use the matrix notation if you want to use the matrix notation, but that one is a long dry where you say Y prime 1, 1 prime Y. This is the same as summation of Y squared. So you have this information, guys. So what is important now is how do you interpret what? So I will ask you to find, so the SSE from the numerator, this SSE, this is the SSE from the overall model. And someone told me that is 111 point something something in the morning. So you must first find SSE of x1 by saying SST minus SSR of x2. Same applies to SSE of x1 is SST. SST will never change because it only involves what? Y values. So it won't change. So you use that 23.773. So based on the what class example, you can share with them, guys, if you don't mind. Can someone give us Yes, leadership.
So since the formula for R squared is SST over SSR, why here are we not using SSR, partial SSR? Why for the R squared for x1 given x2, why don't we say SST over SSR of x1?
You are referring to which section, leadership?
What we are doing here.
It's from there. If we check the way it is written from the guide, let me check the way it is written from the guide, because I think I summarized it. Instead, I just summarized it. I thought this is the quicker method. Let me check from the guide. I think from the guide is I think it's written like that. Let me check your study guide. Oh, was there two ways of writing this? Not this one. I'll find another. The method that you're talking about, it is there. You are right, where you can use SSR, but I feel it will end up confusing you, because this we can change to what we are saying, but I suspect at the end of the day it can confuse you. So I cancel this. That's why let me minimize it and share the screen again. Because let me write the equation again. R squared of y x1 given x2. This is the same as, I said, this 1 minus SSE over SSE of, but we know this is the same as SSE of x2 minus SSE divided by SSE of x2. That one is the same as what? SST minus SSR of x2 minus, in bracket, SST minus SSR divided by SST minus SSR of x2, which is the same as, what is the numerator now? It's SSR minus SSR of x2 divided by SST minus SSR of x2. Is it not something like this, leadership?
Oh, now,
Leadership, I think that
yeah, I was
it's the same,
saying,
isn't it?
I thought
So if you want to take the root of SSR, it will take you back to this one.
Oh, I wasn't thinking about this one.
Oh, you're talking about which one, leadership?
I thought you were going to have only SST at the bottom, and then at the top you're going to have SSR of x2 or x1.
No. Yeah, that one, if you are not, remember, why we're dividing, we're given x2, that x2 is already in the model. Don't confuse the two, because here now, x2 is what? It's already in the model. It's not the same as r squared of y x1 and x2. This one you are right is what? SSR divided by SST. But now, because you are given, that is why now we're bringing in what? The division sign. So don't confuse the two. I thought maybe you are saying you are not happy with the SSE. You want to, you have a problem to only involve SSR or SST. So even this formula, if you don't prefer SSE, you can still use the formula like this. So it's still fine. We'll reach the same answers. So I want you guys to give me the values from class example. So let's help the other guys. That what was our SSR of x1 and SSR of x2 and SSE of the overall model. From there, having this information, we'll be able to find, because we agreed that SSR of x1 is the same as MR of x1. This is the same as MR of x2. Can you please give me the answers for this one based on the class example? Yeah, you won't have this information if you didn't come to our Friday class. Can I get the answers, guys, please? Let's move.
SSE is 118.58. 111.
What?
111.58.
0.58. Yes, let's go to this one.
SSR of x2 is 49.87.
Yes.
And then for x1 is 2255.9.
2255.9. Can someone confirm the values? So now I want you to find R squared of x1 given x2. I said this is the same as 1 minus SSE divided by SSE of x2, the given one, y r squared of x2 given x1, 1 minus SS divided by SSE of x1. Can you please give me the final answers for the two? We can also help you maybe to make your life easy. And SST is given by is what? 2373. So you have that information, guys. Find the answers for those two. Let's interpret them. You let me know when you are done. How far, guys?
First one is 0.952.
The first one is 0.952. Can we confirm the value? The second one?
The second one is 0.047.
Yes. now we have the 2. It's time now to do what? To interpret the meaning. To interpret the meaning. So the one that is given, you hold it constant. So you will say, holding constant the effect of what? We're interpreting this 0,952. This one here. We want to interpret this value. So holding constant the effect of x2. How many percent? 95.2% of the variation in y can be explained by what? Can be explained by x1, which is the size. I repeat, holding constant the effect of x2, which is the age, 95.2% of the variation in y can be explained by the variation in x1. Can someone try 0,047 for us, please? Yes, leadership.
Holding constant x1,
Yes.
47% of the
How did you
variation,
get 47? How did you get 47, leadership?
because I multiplied it
Multiply it.
Oh, it's
Multiply it now.
4.7%. I mean, say
Thank you.
4.7% in the variation in y can be explained by x2.
Can be explained by x2. Can another person try, please? You are right, leadership. I just want to check if they heard what you said. Can another person? Yes, leadership.
Holding constant the effect of x1,
Yes.
4.7% of the variation in y can be explained by the variation in x2.
Thank you very much. So that's how you interpret the what? This partial coefficient of determination. Don't confuse it with r squared. The general r squared, or let us bring let us bring in r squared. R squared. Let's check the difference. At first, we interpreted what is r squared. We said r squared is equal to what? What was the value of r squared in the morning? SST divided by SSR divided by SST. We said is what in the morning? Can I get the value? I cannot see the screen.
It's 0
Can I get the value? You said it's 0,
0.952.
0.9. I cannot hear you. The general one
0.952.
is the same. It's the same with this one.
Yes, it's the same.
Yes.
Yes, but when let's assuming that this one is from SSR over SST. Can someone interpret this one now? This one. How do you interpret this one?
Holding
Yes, leadership.
95% of the variation is in y is explained by x1 and x2.
Thank you very much. You see, there's a difference now. This one we are saying 95.2% of the variation in y can be explained by the variations in what? In x1 and x2. But with the one that we're doing now, we have to, the one that is given, we hold it constant. Thank you very much. So now, under this chapter, what is left is what? What is left is the confidence intervals for what? Is the confidence interval for the mean and the confidence interval for individual value of y, or the prediction interval. These are the only two things that are left in this chapter. So now, if you recall very well in the morning or last week, what we've done is that we tested, we're having a model, like this was our model 12.83 size minus 0.05 age. This is the model that we're having last week, and then you tested using partial f, confidence interval for the BIs, and the t-test. And what you said, that you said when you're testing for age, this I'm just recapping. When you're testing for age, you said what? Age is what? Make significant contribution, isn't it? Significant contribution. But size, sorry, but age does not make a significant, yes, leadership contribution.
Sir,
Yes.
yeah, let's take a break. We'll come back at 55.
At what time is it?
45.
45. Okay, we'll come back at what time? 55. So we'll continue from here. I'm going to, let me just give you a direction what we'll be doing when we come from after break. Instead of us deciding which variable remains, which one is leaving, we can use a system. There are methods that can be used to help you to remove some variables which are not making significant contribution in our model. So that's what we'll be discussing in the afternoon. Sorry, in the next period. Thank you, Mrs. Manga. Let's meet after the 10 minutes break.
Let's continue, sir. Mr. Malek. Mr. Malek. Let's continue.
Yes, sir. Thank you. So, as I explained before the break, what we'll be doing now is, if you remember, I asked you to test using the t-test. Oh, I'm not sharing, sorry. I thought I'm sharing the screen. This technology, no? Don't blame me. What I've been asking you last week, it was to test using any of these three methods, and based on your findings, I asked you to give me what the final model. So based on this class example, if I recall very well, your final model at the end, it was having what 10 plus 12,83 size. You said this is your final model. Reason, you said when you're testing for the relationship between age and y, the relationship was not there. But when you're testing for the relationship between size and y, you notice that the relationship exists between size and y. So you only leave the variables which are what? Which are significant. So there are methods that can be used to do that. Instead of you doing it manual, there are methods that can be used to help you to what? To remove those variables. So we have I don't know, should I call it 4 methods? We have 4 methods that can be used to help you to remove the variables. So these 4 methods, let me call this section variable selection method. Selection method. This one I'm just going to explain the theory part of it. Next week we'll use the system now, SPSS or SAS, so that whatever I'll be explaining, you'll be able to see it when I run the results. One, we have the enter method. Usually it's 3 methods, but if I don't explain this one, the first one, students get confused. 2, backward selection method. 3, forward selection method. Sometimes you'll find the method instead of saying selection, they use backward elimination and stepwise elimination method. These are the 4 methods that will be used to assess if the variable is if it's necessary to have the variable in our model or not. So let's go to the first one. The first one is what we have been doing so far, where you will find the model, test for beta 1, beta 2, beta 3, and so forth. But this first method, it won't help you to remove the insignificant variables. Get my point right? The first method won't help you to remove the what? The insignificant variables. What it's going to do, if you are having y as the dependent variable and 7 independent variables, what this method is going to do, I'll write the other ones. Let me just remove this, the other method, so that I can remain with the one that I'm explaining. The backward elimination method, enter method. If you are having 7 independent variables, what this method is going to do, it will give you the BI. What is happening now? Sorry. This method, it will give you what? The BIs together with what? T tabulated or also, no, not T tabulated, T calculated, not T tabulated, T calculated, and the P value. Maybe it's B1, value for B2, the estimated values B3, B4, up to what? So suppose we have 7 independent variables up to B7. Together with what? They are T tabulated, T calculated, and what? The P values. So by looking at your P values, you'll be able to tell which variable is important in being in the model, which variable is not important to be in the model. For example, suppose our alpha is 0.05%, and your P values, maybe the first P value here is 0.6, 0.9, 0.03, 0.0001, 0.9, 0.2. Suppose we have these P values. I will explain how it works. I don't want to confuse you with this these lines here. 1, 2, 3, 4, 5, 6. I said we have 7. It's fine. Let's remove this one. Let's suppose this one is the 6th one. It means here is where you don't understand, please allow me to pause. I will pause and then explain whatever I don't understand. So now you have these P values. Obvious, B1 goes with X1, B2 goes with X2, B3 goes with X4, and B3 goes with X3, and so forth. So now, if your P value, so the condition that we are going to use to check which ones are significant, which ones are not significant, if your P value is less than alpha, you reject A0. If your P value is less than alpha, you reject the null hypothesis. So based on my example there, if I could give you this table and ask you to write the final model, which parameters will be part of the model? Which parameters will be part of the model? Here's the condition. You use this condition. If your P value is less than alpha, it means that variable qualifies to be part of the model. If your P value is greater than, you are simply saying there is no relationship between that variable with what? With y. For example, let's go to the first one. Is 0.6 greater than alpha? Is 0.6 greater than alpha or less than?
It's greater, sir.
It's greater than.
What does it mean? What does it mean?
It means it won't be part of the model, beta 1.
It won't be part of the model. So which one will be part of the model? Or can you please give me the final model? Based on these P values and the alpha, can you please give me the final model? This section, we'll be using those softwares to explain some of this. I'm just giving you a hint on what will be happening. Can someone give me the final model?
Sir,
Yes.
I think the final model we're going to have yi is given by
Wait.
beta
Yi.
is given by
Yes.
beta 0 hat
Yes. Yes.
plus beta hat 3 x3.
Beta hat 3. Assuming that all our betas are positive, because it's
Yes,
possible to
and
have a negative
plus
beta.
beta hat 4
Beta hat 4.
x4,
X4.
and the
Yes.
rest will be out.
And the rest will be out. Do you agree with what Mr. Smanga is saying?
Yes.
Final model. So you see what happened when using the enter method, it won't help you to remove variables which are not significant. But based on, if I can ask you to give me the final model, it means you must check, you must only remain with the ones which are what, which are significant. I can simply say predict the value of y, only focusing on the variables which are significant. You must be able to say no. You should know that you must first write your model as beta 0 plus beta 3 x3 plus beta 4 x4, and you predict using that model. Yes, leadership.
So on the p-value, shouldn't we have an
Yes.
equal sign less than or equals alpha?
Less
Or
than, or yeah, there are some
yeah.
textbooks which uses this method, less than or equal to alpha. So we have to check that. We have to be careful when coming to that one, leadership, because if I may ask, if the p-value is equal to alpha, what is your decision? If they're equal,
Fail to reject.
fail to reject. If they're equal, you fail to reject. So be careful with that one. You can go and check it, even from the internet, the books, and check which one is correct. It's very, very important. That question that we asked is very, very important. It's possible that the p-value can be equal to alpha. So then what is the decision? So can I move the second method? I just want to explain the theory part of it. From there, we call it a day. Next week, when we meet, now I will move to the system now. I will run the results. We have to apply this, the theory that I'm giving you now. Now, the other method that I explained, I indicated is what is backward elimination method. So I will explain how this method works. Backward elimination method. This is the second method, backward elimination method. So the steps that we have to follow. Backward elimination method start with all independent variables. This is step number one. So when you run the problem, suppose we have 6 independent variables. The first step, here we're talking about steps now. The first step will have all the independent variables. So the first part that we are going to see is the one that we are seeing now. If you can check, I said our model is having how many? I said our model is having 6 independent variables. So this will be what? Your step one. This will be a step one with all independent variables. Now, remember, we're saying this are what? I'm saying this backward elimination method. So now we'll start to do what? To eliminate. Can I please change this one because there's a tie here? I don't want to start with these complex examples. It's still insignificant. So based on this result, stepwise elimination method will say that you check the first step, and we notice that B1 x1 is not significant, isn't it? Is 0.6. X2, which goes with beta 2, is not significant. X5 and X6, they are not significant. So you start eliminating now. You don't eliminate the 4 at once. You check the one which is highly insignificant, the one with the largest p-value that is not significant will be removed first. Which one are you going to remove? You know that we have 4 which are not significant.
B1, B2.
You have this one is not significant, this one is not significant, this one is not significant, and the last one is not significant. Which one will you remove first?
B2.
So
Beta 2 here.
when you say you remove, you are not removing the coefficient, isn't it? You remove the independent variable. Which independent variable will you remove?
X2.
You will remove x2. X2 will be the first variable to be removed in the model. Why? Because it's the one which is having the largest p-value that is not significant. So what is happening with backward elimination method? It removes one variable at a time. There won't be a stage where it will remove 2 variables because they're all not significant. No, it doesn't work like that. It will first remove the variable that is not what? That is not that is highly insignificant. If you can check so far, we have 4 which are not significant, but we cannot remove 4 at once. We have to first remove the one which is highly insignificant. So in our case, you are saying x2 will be the first variable to be removed. So what is going to happen now? The software that we'll be using, it will move to another step now. Maybe we'll call it step number 2. Step number 2, it is going to fit the module again, but without x2. So you'll fit the module again, but now with x1, x3, x4, x5, and x6. You repeat the same thing. You check the p-values. Remember, immediately when you remove x2, obviously your betas will be affected, isn't it? So when you remove your x2, it means you'll be left with x1, x3, x4, x5. You run the module again without x2. You check the p-values. The one which is highly insignificant, you remove it. You remove it from the module. You repeat the statement until the remaining independent variables are significant. So which means the system will only stop when the remaining independent variables in the module are what? Are significant. Let me repeat. Step 1, the module will start with all the independent variable. This method eliminate one variable at a time. That is the second. That is another part that you must write down. And then it will remove the first variable to be removed is the one that is highly insignificant when compared to what with alpha, like in our case we said x2. After removing that x2, we run the module again without x2. We check the p-values again. The one which is highly insignificant, we remove it. Remember that these p-values will be changing. As long as you remove something, the p-values will keep on changing. The system will only stop when the remaining independent variables are less than, their p-values are less than alpha. In our case, we gave an example of 5%. So the system will only stop if the p-values that are there are less than 5%. Can someone explain what I just explained? Yes, leadership.
Okay, so what you are saying, this backward elimination method, we
Yes.
start with all variables, all independent variables. Then
Yes.
we are going to check their p-values. So the one
Yes.
which is highly insignificant, which means is the one that is having the greater, like the high p-value than
Yes.
others. So we're going to remove it. Then after removing it, we'll repeat the process again without that a variable which we removed, and also the p-values are going to change. So we're
Yes.
going to remove the second one, which will be highly significant. After removing that one, then we
Yes.
continue with the process until all the variables which are left are significant. It means their p-values will be less than alpha.
Thank you very much. So when you are asked to write the final model, it means you'll focus on what? On the last stage, last step. Let's take if the system decides to stop at step 6. So if I ask you to give me the final model, you have to write the betas of step number 6, because that's where the system stopped. So that's how we apply backward elimination method. I said you start with what? The first step is start with all independent variables in the model. In the what? In the model. But it is start removing what? One variable at time. Get that one? So the practical part of what I'm saying, we'll do it next week. I just want to introduce you to this part. So now, let me bring in, you see this one, it was called the forward elimination method. So the backward elimination method is what? Is the opposite. Forward elimination method. Forward elimination method, another method that can be used. How does it work? Method number 2. Um, method number 2. Forward elimination method. This one, point number 1, start with a null model. This one start with no independent variable in the model. So how do we select the first, which variable? Remember, we have x1 in our case, x2 up to what? x6. This one is called forward elimination method. Variables will be entered in the model one after another. So let's say we have x1 up to x6. Which one is entered first? That is the question that we have to ask yourself. You have y, x1, x2, x3, x4, x5, and x6. Which variable to be entered first? Because I said you will enter these independent variables one at a time. So what you do now, you will first find y of x2, y of x3, up to y of, you find what? You first find correlation coefficient. What am I saying by this? The variable that is highly correlated with y will be entered first. So suppose r between y and x1 is 0, 0.6, 0, 0.9, 0, 0.99, 0, 0.2, 1, 2, 3, 4, 0, 0.3, 0, 8. I'm not sure if you can see this. Well, let me write them here. I will delete them. R for when between y and x1 is 0.9. I'm just giving an example here. R is 0.6 between y and x3. But it doesn't matter. Even if I don't write all of them. 4, 0.2, y and x4, y and x5, 0.9, 7, y and x6, 0.22. I said the variable that is highly significant, that is highly correlated with y will be entered first. This is forward elimination method. So suppose we have these values here. Which variable will be entered first in the model? Yes, leadership?
So about this forward elimination method, if I
Yes.
can say the model start with yi is beta 0 head, will I be wrong?
It's true. That's what I mean when I say the null model.
Okay, thank you. And about the you are seeing the variable that will be entered first is the one which will be highly correlated. Does highly correlated mean more significant?
Highly correlated. You are talking about the relationship here. The relationship, the one that is having a strong positive, a good relationship with y.
Okay, so which means here we are testing the relationship, not
Yes,
the
we fed, but the system won't show you this part. Won't show you why the variable was maybe why x5 was entered first. The system won't tell you that or won't show you that, but you must know why x5 was entered first.
Okay, thank you.
Yes. So based on my R here, the R that I am having here, which one do you think will be entered first?
Y X5.
Y x5. Because Y x5 is there's the 97% oh, that one is the relationship, isn't it? There's a strong positive relationship between Y and x5. So x5 will be the one that is entered first. I will stop after explaining this one. The stepwise elimination method, we can do it next week. It's not a problem. Next week. So it's fine. Now we understand that part. X5 will be entered first in the model. So this is what forward elimination method. You said X5 will be entered first. So you run the model with, because you said X5 will be entered first. Step number one, because we said the one that is highly correlated with Y will be entered first. Now you run the model with Y and X5 based on our example. It's not always the case. It's both based on what was given there. And then this variable will be tested, tested with Y. And then you will have its p-value. Second step, the second variable to be entered will be based on partial correlation coefficient. Given that the other variables will be entered, given that x5 is already in the model. So now you're going to check x1 given x5, x2 given x5, x3 given x5, x4 given x5, x5 given, or x6 given x5. So now, remember the first one was entered based on what? The correlation coefficient, not the conditional one. Now, because we have what? we have x5 which is already in the model, you will say that for me to bring in x1, given that x5 is already in the model, you'll be guided by what? By the values. The one with the highest value will be entered next. Suppose, let's just write the values. Let's say this one is 0, 0.6, 0, 0.2, 0, 0.7, 0, 0.8, 0, 0.4. I said this is 0, 0.6. So which variable do you think will follow x5 based on those values? Now this one you check based on what? Partial correlation coefficient. Which variable do you think will follow x5?
X6 will follow.
X6 will follow. So next step you'll have what? Y, x5, and x6. Now when you feed the model, you'll have what? Y, x5, and x6. You will continue with the process. This is the tricky one now. You will continue with the process until all the independent variables that qualifies to be entered are entered. Let me repeat my statement. You will repeat the process until all the independent variables that qualifies to be in the model, that qualifies to be entered in the model are entered. It doesn't mean that because you have x1 up to x6, at the end of the day, we have to bring them in. There will be a stage where the system will stop. If the system stop after entering maybe only 4 independent variables, you conclude that the ones which were not entered in the model, they don't meet the criteria of entering in the model. Let me repeat that. This method, it's not a must that all the independent variables should be entered in the model. They will be entered if and only if they qualify to be entered. For example, let's go back to qualifying for the exam. You will be writing tests, you'll be writing quizzes, you'll be writing assignments, but for you to qualify for the exam, we need an entry level, isn't it? We will say that we won't say because you all wrote what the test, the quizzes, and the assignments. You should go and write the exam. No, only those who will meet the criteria of what 40% will be allowed to do what, to go and write that exam. We won't say because everyone managed to write test 1, test 2, quiz 1, quiz 2, and assignment, now we will allow them to go and write the exam. No, same applies to what is going to happen here. You have 6 independent variables. Variables will be entered based on what? Based on they will be competing, like what now one when we bring in the partial coefficient, they will be competing until some of them will won't fit the minimum requirement of entering. Again, this part, whenever you are running the program, the system won't show you why the second variable was why a certain variable was included in the module the second time or the third time. But you must know the process that is happening behind. So the system will stop only if the variables that qualifies to be entered in the model that are what they are entered. So it doesn't mean that because we have 6 independent variables, it's a must that we must enter the 6. The last one that is tricky now, this method will not only always give you a final, the last step, which is significant. This method will not always give you the last step, which is significant. Remember, when coming to backward elimination method, I said the last step, it will give you what? The variables that are what? That are important in predicting y. But when coming to the forward elimination method, the final model is not always having significant variables. So it's your responsibility that when the system stops, you go to that final last step and check which variables can I take. Can I say now these ones are important in predicting y. Why is it the case? Because once you enter the variable when dealing with forward elimination method, it can become insignificant along the way, but you cannot remove it. Once you enter the variable in the model, you are stuck with that variable. Even if it becomes insignificant, the system won't help you to remove it. That is why it's not always the case that at the end you'll be remaining with significant variables. Can someone explain that statement? That's this method, and then we call it a day. Can someone explain it, please? In less than 2 minutes. Can someone give it a try? Or I confused you guys. It's fine. If you are still confused, let me start from this method next week, Thursday. Please attend our next week class, because that will help us to also agree about the scope for the quiz that will be written the following Tuesday. So we're going to use a time series slot to write that quiz. We'll use time series slot, the Tuesday slot for time series, to write that quiz. So go and check what time were you supposed to attend time series. I'm not sure if it's a tutorial or it's a class on Tuesday. During that time, we're going to use that time to write what? Our quiz. I thank you. Any question?
Sir,
Yes.
about this forward elimination method, you said it's to check the correlation. So,
Yes, the first step.
is it possible that the model which is highly correlated with the one we insert first, it will
Yes.
it will not be significant? So you said the last step, it won't be
Yes. Thank
significant.
you. Thank you. It's Mr. Manga, right?
Yes.
Yes. Remember, now we have what we call multicollinearity. The more you include the variables, the independent variables, the more they affect each other.
Mm.
They affect each other. So it's possible that you may find that X5 was entered first, but along the way, that X5 now is no longer significant. There's what we call multicollinearity, where you find that we have independent variables that are highly correlated. Remember, what we have checked, we're checking now, we're checking if there is a relationship between Y and X, isn't it? But there'll be a case where you find that we want to check if X1 is not correlated with X2. And imagine, suppose you want to find the correlation between Y, let's take X5 and X2. You find the value is 0.9. This is a problem. We don't want to see what in our independent variables correlated. We don't want that. So these are some of the things that can affect our results. We're going to check that one when we get to chapter 4, which is when testing for multicollinearity. Multicollinearity is when our independent variables are correlated, which can create problems in what? In our analysis. Yes, leadership?
Sir,
Yes, leadership.
is the quiz next week Tuesday or that other week?
It's after Good Friday.
Oh, okay. Thank you.
Enjoy. Questions, please?
Sir,
Yes.
what is the condition which like it stops the system from allowing those independent variables to enter the model?
Is
Is that
there's what we call there's what that one I can easily explain it next week when we're doing the practicals. There's what we call significant level for entry, significant level for entry, and significant level for removal. It is there whenever we run the results. I will show you where you can change it. It's there from the system. There's a default one, uh, but we call it SLE and SLR. SLE it means significant level for for entry. SLR significant level for removal.
okay? So there is no way we will be expected to calculate it.
No. There's no that you should do. That's why even whatever these things that I'm explaining of Rx1 given x2, you won't see it. If you're asked to interpret an output, I won't ask you to calculate these things. I'm just explaining what is happening, why this a certain variable will be entered first, how the system is going to enter the second variable, why the system, why in a case where the system will stop without entering all of them, what could be the reason behind that? That is why I'm just explaining these things here. But whenever you are writing test, I won't ask you to give me this information. But you must know whenever, because I can ask you why the system stopped without entering certain variables. Do you understand leadership? Let's say why the
Yes,
system
I
decided to
understand.
stop without entering maybe X4. You must be able to tell that no, X4. It means it didn't meet the criteria of entering. That is the answer that I'm
Oh,
looking for. If it was not included, means it didn't meet the requirement for what? For entering the model. It's not like the system made a mistake. No. It's like leadership. When you are applying to be a student in the University of Limpopo, um, you sent your grade 12 results, isn't it, leadership?
yes.
And then we check the results. There are people who were rejected. They didn't meet the criteria of what? Of entering. But they have applied. That's what also this system is doing. You don't, we don't give you a chance because we have applied. No, we check if you qualify to do computer science. So if you don't
Oh,
apply, we won't include you what on the list of people who are accepted to do computer science. So
okay.
the
So
person
even
didn't meet the criteria, the minimum criteria of what? Of entering. Same applies to this method.
all right. Okay, see, I
Yes.
understand.
Thank you, leadership. Another question, please. Are we cool? Are we fine, guys?
Yeah, thank you, sir. What a lovely
Okay.
session. See you next week.
Hey, so Smanga, you cannot wait to disappear. So this method, I noticed, I understand maybe you are tired. There's been a long day. This method, I can I can explain it again next week when we meet. Um, expect my questions as leadership Malepe requested. Expect my questions. I will send questions. I can also maybe share one previous question paper that you can solve. Check if you are following whatever we're doing here. I can share one exam question paper and we try to solve it because most of the things that are supposed to be covered under chapter 3, we've covered them. So I can share one previous question paper that you can try to solve and check if you follow. Because now what I've noticed when I was discussing with leadership Chabalala is that the understanding is there, not for from all the students. I want to be honest, but it seems like you are failing to present what you know. You are failing to put the things that you know in so that someone can understand. For some of you, you when the way you're writing, it's like you are signing. It's not easy. Some of the things to read here, we have to assume. We have to assume what we are saying. Do you understand, guys? So thank you very much. I will see you tomorrow during the tutorials. So I will join 30 minutes late. I will allow you to do the problems. I will allow you to do the problems. After 20 minutes, it means I will join the tutorial at what time? At 20 past. Yeah, I will be late maybe 30 minutes so to allow you guys to discuss if you want to discuss with your classmates. And then 20 past 4, 20 past what? 20 past 3, I will join the tutorials. So that wherever you're having some challenges, you can ask me. I think. So
Sir,
don't be surprised yes.
can you also share the notes that you are using when lecturing?
Yes, I said I would do that leadership. I forgot. But again, I wanted to cover what